Hello, can you see me now? I'm really hoping this is going to work. Can you see me? Yay! Okay. It's official. Your teacher is a... Oh, don't say no. Pablo can see me. Good. Wow. Okay. That was complicated. So I had spent 10 minutes streaming to myself on last week's stream. So this is what happens if you put streaming software in the hands of an idiot. So guys, I'm very sorry. That's just poor. Welcome to all of you for helping me out. I mean, I was thinking, you started off and I was thinking, there's just no one here. So Laura, I'm here. I thought you were talking about Decent. Manor, nice to see you. Sanuka, thanks for being here. Rukshan, hello. Dom, hello. Decent. Yeah, you were late, but not as late as me, so it seems. Who else have we got in here? We've got Manor, we've got... So there we are. I've got Pablo in here somewhere. Hello, Pablo. So, yeah, I'm basically a gigantic loser. So there we are. I've got Rukshan. I've got the optical Malm. Nice to see you. The optical Malm. Hi, sir. No, I didn't. I remembered you, the optical Malm. It just took me a while to get don't be sad, just to get my head around it. Haroon, how are you? Well, Haroon, you've missed nothing because basically I'm a moron. So we'll get started. Thanks for being here, guys. There are loads of you here, so let's crack on. I was going to ask some questions, but I've already wasted 50 minutes of time. So let me whiz through this quickly, rather than taking ages. Of course, I would never have left you out. So we covered this in the first week. This one. This is an answer from a past paper. Any idea what's the question? This is the answer. What was the question about? Do you remember? This was to do with memory, and this was to do with this is quite a tricky question. And when they chuck it in there, it's often worth quite a few marks. Can any of you remember what this was about? Disk thrashing, slower than direct RAM access. Any ideas with that at all? I'll put you out of my misery. This was to do with virtual memory. So remember, virtual memory is when you use a part of your hard drive as RAM, and boom, it's helpful because you can use your hard drive, but the problem is it's slower and it wrecks. Yeah, exactly. Writing in virtual memory, it's harder because it wrecks your hard drive, called disk thrashing, right? So that is that one. The lag today is quite long. It's about 10 seconds between me and you. All right. This one, I keep doing this one because they're so hard to remember. Can any of you work out what is A, B, C, and D? So if you do A answer, B answer, C answer, D answer, what's this? Stores address where data will be read. They love this in the exam, and they seem to shove this into every single one they do. CPU, first topic. Right, what have we got? Stores, or put in the ones that you know. Which one? A, M, A, R. It's got address in it, which is a good thing, isn't it? The address, we know the A part. We've got the M, A, R, A, M, A, R. Okay, so we've got Pablo and Decent there. We've got Decent M, A, R for A. We've got Pablo M, A, R for A. Haroon M, A, R for A. C, A, L, U, arithmetic logic unit. Okay. What about B, C, and D? What do you reckon about those? Stores data fetched from memory. Stores results of calculation. Hang on, we've got Pablo. MAR, MDR, ACC, PC. Shall we see? Shall we see what the answer is? It was. I think you got it right there. MAR, MDR, accumulator, and PC. So that is for Pablo. MAR, the A stands for address, the memory address register. That's where the data is read from. MDR, that's the data fetched from memory. Let's have a look what Rukshan's got here. He's got memory address register, yeah, memory data register, accumulator, You know, you got the last two mixed up, but almost there. The accumulator, that's part of the calculator, isn't it? Of the arithmetic logic unit. That's where the interim results are stored. And the PC points to the next address. So if each week you can tick off one of these, because there's a possible 4 or 5 marks in this, which ones are registers, which ones are components. DPC, yes. Rukshan, you're on it, absolutely spot on. So guys, that is pretty outstanding there. All right, so that is that first one done. Come on. Right, what's it all about? So we're going to look at, we've looked at memory storage. This is what we're going to look at. This is from the specification. So top left, you've got this business with bit, nibble, byte, all that sort of stuff. And I'll whiz through that fairly quickly because that's quite easy. But then I'll focus for the most part on the number conversion. You lot are generally pretty good at maths. So it's really a question of just reminding you how to do it, because there's not particularly any hard maths in here. It's mainly about remembering the steps you've got to do, but I guess that's maths all the way through, isn't it? Okay, so let's push on to this one here, the 10-minute teach, numbers, All right, this very often crops up at the very start of this section, and this is the sort of the relatively easy one marker to get you going. And the question is, why do computers use binary? And your 1 mark answer to that is to say that it is because computers consist of transistors and circuits. It's electronic circuitry, and they can easily be represented in binary. So literally the computer circuitry is on off, and therefore it can be represented with 1s and 0s. So that is your first mark or 2. A nice easy way into the exam. So that's why computers use binary. This next bit, this is where they'll get you to do some math to convert from bits to nibbles to bytes to gigabytes to terabytes. So this is relatively straightforward, but it starts, the most complex bit is at the very start. So let's start at the beginning, which is over here. The smallest unit is the bit, which stands for binary digit, and that's either a 1 or a 0, okay? That's easy peasy. The next one you've got, and I've just skipped back, let's get back here again. The next one is the nibble. A nibble consists of 4 bits. And the next one is the byte, and that consists of 8 bits. That's the hard bit. Once you get to byte, everything increases by magnitude of 1,000, right? So for example, a kilobyte is 1,000 bytes, just here, okay? Or 10 to the power of 3. A megabyte is 1,000 kilobytes. Oh no, over here. A megabyte is 1,000 kilobytes. A gigabyte is 1,000 megabytes. A terabyte is 1,000 gigabytes. And guess what? A petabyte is 1,000 terabytes. So that is all you need to know. And they'll ask you to do some maths around converting from kilobytes to megabytes. And once you go beyond bytes, you're just doing it in thousands, right? Kilobyte, megabyte, gigabyte, terabyte, petabyte. So as long as you know which one's bigger than the other, which you generally do, because you know when you're mucking around with file sizes and with your Xboxes and PlayStations, you use that. All right, so they might go from that onto this type of a question. This is new for this syllabus, which is you've got to calculate the size of different file types. And we've got a sound file, an image file, and a text file. Let's do the text file first because it's the easiest to do, right? So the text file is a question. If you want to calculate the size, as in how many megabytes or kilobytes a file is, for a text file, it's the bits per character times number of characters. And to be honest with you, that one's quite easy because A, it's only 2, and B, character and character, it's going to be to do with text, isn't it? So that's not so bad. Then you've got image file. Slightly more complex, and it's a good time to tidy up your understanding of color depth and what that means. All right, so color depth times image height times image width. So these two here, this is broadly referred to as image resolution. So it's the physical size of the image, how many pixels across and how many pixels up, yeah, and you multiply that by the color depth, and that gives you the file size, okay, an image file size. Lastly, did it again. Lastly, we've got sample rate. we've got sound file, sorry. To calculate a sound file, you've got the sample rate, which is how many times a second the file is sampled or recorded, times duration, which is the length of the file in seconds. And if they want to do a grade 9, grade 8 question, they'd say 1 minute 30 seconds just to be mean. So that's going to be multiplied by 90 because it's in seconds. Are you with me there? And then you've got to multiply that by the bit depth. So you're going to need to make sure that you know those different calculations, all right? That wasn't in the last exam, and they didn't, and they've just introduced this newly, if that's a word, to the spec. It wasn't in the last one, so I fancy they might put something in there on that. You know how they love to build a question from sort of showing that they might say put these in order of size, bit, byte, megabyte, nibble, petabyte, and then get you to say, to find out, to calculate the size of an image file, you'd multiply which by which. You might need to draw, lines to one of them, and then to actually make you work out the file size, okay? And then the last part of it could be to say which storage device would you use to hold this amount of data. So you need to understand that, for example, the smallest and the least expensive, and with the slow read-write speeds, is a CD-ROM, only holds 640 meg. And to be honest with you, no one saves things on CDs anymore. Then you've got DVDs, a bit more expensive. They can hold 4.7 gig. The dual layer ones can hold double that. And then you've got Blu-ray, which if you've got a PlayStation or the latest Xbox, they'll play Blu-ray video movies for you, 50 gig. USB flash drive, up to 2 terabyte. And then SSDs. And the point here is, if you want the largest size, you'd go for this one here, the magnetic hard drive. They've still got the biggest potential storage capacity at 12. Whether it's still 12, it could be 14, it could be 20. But the point is, the SSD, it's faster, it's more expensive, it's got faster read-write speed. But in terms of total capacity, a solid-state hard disk drive would be that. There is one more, actually, the tape drive. Tape drive, very slow read-write speeds, but it's got a gigantic storage capacity, which is why it's used to back up data overnight in businesses. All right, so that is that. I want to get on to the main part of this, really, which is the calculations. And like I say, this for most of you is just a question of, there's a large spider there, just a question of reminding yourselves how to do it. So we're looking at 3 different number systems. We've got binary, which is zeros and ones. We've got denary, base 10, our number system, decimal, which uses 0 to 9, which if you count from 0 to 9 requires 10 fingers or 8 fingers and 2 opposable thumbs. So denary 0 to 9, then hex goes from 0 to 9, and then A, B, C, D, E, F, right? So those are the 3 that we need to focus on, and they can make you jump between one and the other. So I'll send you this PDF, but I'll whiz through really quickly how it is that you go about doing these conversions, because this is, again, something that's hugely likely to turn up. So binary first, right? So here's the question. The question up at the top here is convert this binary number, and you can tell that it's a binary number because they've put this little 2 down here, okay? So that is a base 2 number. So you've got to convert this binary number to denary. Doesn't matter how good your maths is, as long as you can draw this little table down here, nothing can go wrong. Even if you're sleepwalking, it's that easy, but you do need to draw the table. Things that can go wrong with the table is that you start with 1 on the left-hand side, not the right-hand side, or that you start with 2. So it goes 1, 2, 4, 8, 16, 32, 1, 2, 8, which is how you buy memory, isn't it? If you buy memory for your phone, you're buying it in 8, 16, 32 gig, 64 gig, 1, 2, 8, okay? And so forth. So number 1, when you're converting from binary to denary, draw this table. Once you've done that, nothing can go wrong. So let's look at the next step. So next step is you've drawn the table, you then drop those numbers, which I took from the top left, and I've dropped them into the table. This may well be coming back to you now. It is then very, very easy. Where you have got a 1, you add it to where else you've got a 1. So it's going to be 128 plus 32 plus 8 plus 2. All right? And that's all you've got to do there. I don't know how far behind me you are, but I will say to you, the answer is, and I'm sure you will get there just before me. 198, Mohammed, how are you, dear boy? Good to see you. Let's have a look. 170. Oh, he's done it twice. Last answer. The answer is 170. Spot on. That is outstanding. Dead easy, isn't it? So binary to denary, 69. You're going further away now. So that is good, okay? That is what we need to do. Draw the table, drop the binary numbers into it, where it's, yeah, exactly, decent, 170, spot on, and that's what you need to do, all right? So that hopefully is... The problem is none of these things on their own are actually difficult. It's when you've got to do several of them in several different ones. That's when it gets more complicated. But that's the first one there, which is going from denary to binary. Okay, next, this is, and again over here, let's try and make sense of this up here. So I'm looking top left here, guys. This one here, there. So this is 170 base 10 to binary. Number one, draw the grid, okay? We do something slightly different, but we still use the same grid. So if you're converting to or from binary, this grid is the way to go. Even if your maths is really, really good, experience tells me that drawing the grid, because it's very easy to make a simple mistake with this, because the maths isn't hard, but it's easy under exam conditions to make a mistake. So my advice to you is you've got enough time, draw the grid and do it that way. Where people try and do it inside their heads, regardless of how good their maths is, it's just easy to make a mistake with mental arithmetic, okay? So, or do it quickly and then go back and check at the end, but I personally would. So 170 base 10. So your question is, what is the largest grid number? And when I say the grid number, I mean the number on this grid. What's the largest grid number, any of these numbers, that goes into our number once? So in other words, I'm looking at the number 170 and thinking, what's the biggest number on my grid that goes into it? And of course, the answer is 128, which means that, guess what? You do some simple maths. So you put a 1 in the 128 box and you work out what the remainder is. And the remainder is, hang on a second. Okay, 128 goes into 170 with a remainder, or mod. Remember, it's modulus is the remainder if they do that in there, because they expect you to know that. So 128 goes in once. Oh, decent's ahead of me here. 128 goes, and the remainder is 42. So then you ask yourself the same question again. I'm guessing you've got this now. So what's the biggest number that goes into 42? It's 32 with 10 left over. What's the biggest number that'll go into it? Yeah, 8 will go in once with 2 left over. So we draw one there, and that's your number, and you fill in the rest with zeros. Okay. So we had, oh crumbs, I keep swiping across here, it's very annoying. So hang on, we had Decent who had 10, 10, 10, 10, 10, that was it. Decent had it right, Mohammed had it right. Rukshan, I don't know, Rukshan's, I think he's making a rocket for the moon. And again, this is all good. It's the right answer to something. I'm just not quite sure what, but I'm fully supportive of your work. So that's that one, okay? I'll be happy with that. It's easy, isn't it? And you've done this before, but just as a recap, that's what, draw the grid. So now hexadecimal, right? So hexadecimal conversions works like this. Just first of all, in terms of understanding it, if you're converting from hex to decimal, you've got to convert it to binary and then convert it to decimal. To be honest with you, if you muck around with these number of systems enough, you can just do it inside your head, but I recommend you don't do that, okay? So that's what you've got to do. So if we're going from hex to decimal, we go from hex to binary and then convert it into decimal first. So let's have a look. So we've got the number 5F that we are converting, okay? So what you create are two nibble tables. Remember the nibble from earlier on, okay? 4 bytes in a nibble. So you simply draw it out. Now the 5 is, what's the biggest number that goes into 5? It's a 4. What's left over, it's a 1. We're doing the same thing again. This is the left-hand side here. And let's think about it. We've got A, B, C, D, E, F. And the F is 8 and 4 is 12, and 2 is 14, and 1 is 15, because F is 15. So you do need to remember that you go from 0 to 9, and then A, B, C, D, E, F. Okay, so that is how it works out. All right, so that's the first step that you would do. You create 2 nibble tables. So it's the same process that we've used before. Okay, nibble tables, I said. Trust you. And then you smash those 2 nibble tables together, and then you're back to doing what you did before. So you've got the 2 nibbles, and then I'm not going to say nibble tables again. You've got the 2 tables, you put them together, and then you do the simple maths, which leaves us with what? I'll sit here and take a sip of my tea. Oh, Rukshan's already come with it. In fact, we've got Rukshan who said 95. We've got Laura who said 95. We've got Rukshan who said 95 again. So I'm convinced this has to be good. We're good with this, guys, aren't we? So I will send you this PDF, which is exactly like this. Just do a few to remind yourself, all right? Nibble table, 95. Yes, that is outstanding, Mohammed. You can have a round of applause, I think. That's the least I can do. Oh, there we go. There's a ding, just to make you feel better. It's all about self-esteem. That's not helpful. Right, binary addition. This is, I was going to say, it's so obvious. This is where you add 2 binary numbers together. Now, people sometimes find this unnecessarily complicated. In order to do binary addition, you need to know 4 simple facts. Honestly, if these 4 simple facts make sense to you, everything else is fine, because this is literally all that you have to do. The first one's obvious, because 0 plus 0 is 0 in any language. 0 plus 1 is 1 in any language, as is 1 plus 0. However, 1 plus 1 equals 1, 0 in binary, not 2. If you write 2, you're definitely going 1 plus 1 is 1, 0, okay? That's the thing to remember. So much so that I've even put it on the left-hand side there to remind you what to do, okay? So this one here, when we're adding things together, 0 plus 0 is 0, 1 plus 1 is 1, 0 plus 1 plus is 1, 1 plus 1, let me get my little thingamy-bob here. Tell I'm not a maths teacher, let's do the draw. So I'm starting here, right? 0 plus 0 is 0. 1 plus 0 is 1. I can't draw a very straight line. 0 plus 1 is 1. This is the exciting part. 1 plus 1 equals 1, 0. 0 down, carry the 1. 1 plus 1 is 1, 0. 0 down, carry the 1. This pen's only making it worse. 0 plus 0 is 0, plus 1 is 1. 0 plus 0 is 0. And if I say 0 or 1 too many more times, I think I might lose the will to live. But can you see how this little thingamy-bob down here that I've done, that honestly, because all you're going to be doing is 1 plus 1, 1, 0, 0 plus 1, 1, 1 plus 0, 0, 0 plus 0, 0. Literally, when you're doing binary, everything applies, start on the right-hand side, and then just do your carries. And that's it. 0 carry 1. Yeah. Okay? So, again, practice a few, but that is literally all you've got to worry about with this binary addition. Oh, an overflow error. Yeah, okay. Have I got overflows in here? I will do overflows again with you. I've got them here. I couldn't remember. I've got binary shifts, overflows, right? So binary shifts are a way that CPUs can multiply data really quickly. Binary shift, you've got 2 types. You've got a right shift, and guess what the other one's called? It's a left shift. What you need to remember is that a right shift is about division and a left shift is about multiplication. And saying left shift is very difficult because I'll end up saying something regrettable. Right and left shift. Right, divide, left, multiply. That's kind of important, right? Because you need to remember which is which. And Decent, you know this question you've asked here, if something drops off the edge of an overflow, if they make you do a binary shift, what drops off the edge is not going to appear in the answer. It's discarded, all right? So let's run through this. In right shifting, which is division, the rightmost bit, the rightmost digit, the rightmost number is discarded, okay? And all the remaining bits go one place to the right, and the empty place on the left is filled with a 0, okay? So that's division. But you can see how each time that you divide, the accuracy of your number is being reduced, yeah? If you left shift, it's exactly the same. You the leftmost bit is discarded, and the remaining bits are moved one place to the left, and the empty bit on the right is filled with a 0. I recommend that you have a go at a few of these, but the key takeaways are right shift division, left shift multiplication. Right shift, you move you get rid of the rightmost digit, you move everything to the right one place, and you fill the empty place on the left with a 0, and it's the inverse for multiplication. So that is your left shift and right shift. Have a practice with that. Again, that wasn't in the last mock paper, so it's a fairly decent bet it may be there this time. Okay. We've got 19 people in. That's really good. I'm really happy with that. And thanks for hanging around, because I was thinking I'm sitting here on my own talking to myself about a subject that I already know about, and that was quite scary and sad. What about this one? During a logical shift left, what to... God, I can't read. Doing a logical shift left. Oh, God, thank you, Rukshan. I'm glad somebody's actually... let's have a look. Rukshan is saying multiply, B. So shall we see how you're all doing? Dom's come in with that as well. Whoa! This thing keeps jumping ahead. I'm going to go back to my back to my trusty mouse. Oh my word! This has gone mad. Come on, go back. Right, just while my computer sorts its life out. Whoa, okay. Now I'd like you to stop. We're now going back into the history of mankind. I've got one of these graphics tablets, and it's great, but it's quite excitable. So the answer was multiply. You're quite right. What about this one? Doing a 2-bit left logical shift after a day at work. That's quite a stressful sentence. Doing a 2-bit left logical shift has what effect? What do we think? So we've got I've got some answers coming up here first. We've got decent, which is D multiplied by 4. Rukshan saying multiply by 4 as well. Should we have a look? The answer is, yeah, Pablo's saying D as well. So is Laura. Let's have a look. You are, oh, come on. Yeah, you're all absolutely spot on. That is what Dom said, B. It is D, okay? So, yeah. That's what you need. Okay, what about this one? Which answer has correctly applied a 1-bit left logical shift to that number? I'm not going to read it out because I've had to say too many ones and zeros. What do we think? Okay, so we have got Rukshan, who's going 0001100, which is A, I think. 00, no, it's not, it's B. Now, you see, you said, okay, we've got Charlie. Hello, Charlie, with B. We've got Nono. We've got that. Shall we see? The answer is D. So, you all messed that one up. Ooh, I've got a... Let's go... there we go. That was a massive disaster. Let's try this one. Oh, just giving it away. All right, next one. State the denary representation of the binary number 00111101. Come on, you lot. You're good at maths. What's this one? What's the binary for this? 89, 61, 71, or 60? What do we think? What does it mean? 89, 61, 70, or 71, or 60? The denary representation for the binary number. Rukshan says 53. It's B, says Laura. I'll give you a clue. It is one of the options here. Pablo says B. We've got Laura and Pablo saying B. We've got B. We've got B. We've got B. Yeah. Well, the world seems to have settled on B. Shall we see if you're right? The answer is B. That is outstanding. Okay. What letters, I think it should be which letters actually, which letters does hexadecimal use? Which letters? A to E, A to G, A to F, A to D. Obviously that's quite important. Which one do we think? Let's have a look. Dom is saying Yusuf, A to F. Hello Yusuf, how you doing dear boy? Thanks for coming. Rukshan, A to F. Decent C, which is A to F. Yeah, okay, good. That obviously, without patronising you, is something you need to remember. What about this one? Convert 173 to 173 decimal, base 10 to binary. What do we think? 173 to binary. I'm guessing a few of you could do it inside your head. If you're finding binary particularly bamboozling, Google 1 to 30 in binary and just try counting from 1 to 15 in binary. And suddenly you'll go, ugh, and you'll get back into it again because it's just one of those things you need to look at a few times. Right, Rukshan, 10101101, 101101, which is B, I think. Yusuf has said C, Rukshan said B. Okay, so hang on, I think Dom said C, or was that for the previous one? Rukshan said B, Yusuf has said C, Laura has said 101001, Okay, so the answer is, ladies and gentlemen, it's B. Yeah, which most of you got right. 1101. Okay, cool. As long as you figured it out, because that's fine. But just that process, right, is the one you need to figure out. Yeah, decent with B, Dom with D. You were almost there, Dom. You were one digit out. Cool. You've got it sorted out, Laura. As long as you figured out what that routine is, because it's not. It's all the ones and zeros. That's why do that table, because it makes life so much more simple. What about this one? Convert the binary number 10101010 to hex. And don't forget, this is when you do two nibble tables. Yes. And you can work through it like that. Okay. And that's what you need to try and figure out how to do it. Now, hang on. Rukshan has gone for AA, which is C. Yeah, C. Gotcha. Any different answers to what Rukshan's got there, or are we all thinking it's a C? It is worth it if you're feeling a bit overwhelmed by the hex. Have a go at a few examples, just until you've got that format inside your head of you do this step, this step, this step. But it's all in this PDF, which I will ping to you after the live stream. So we've got C. Yeah, decent saying C as well. Shall we see if it's C? Come on, computer. It is C. Okay, that is outstanding. Well done, Dom. You are a superstar. And Denary, you're right there. Sorry. Yeah, double AC. You're absolutely right. Absolutely right. That was outstanding. So you think you've got that sorted out. Okay, so revision ideas. Go back and look at those units. Make sure that you're happy in which order they come, that you've got bit, nibble, byte, kilobyte, megabyte, and so on, okay, the order they go in. Then make sure you're happy that it goes, that your bit is one of two different states, and then you've got a nibble, and then you've got the byte, which is 8, okay, and a nibble is half a byte, which is 4, and then it's up by thousands each time. So make sure you're happy with that, and doing a bit of maths with that. And then the why binary question, the idea that it's circuitry that only has 2 states, on and off, and binary can easily on and off can easily be represented in binary because it's one of 2 options. Okay, learn the fixed file size of the storage media. the fact you've got the magnetic media or tape is the largest capacity, and then something like a CD is the lowest at 640 meg, I think it was. Think about the steps you need to learn for binary and hex, and then also about the multiplication that you need to do. What gets multiplied by what in order to calculate the file size of texts, of sound files, and of images. Okay, and that's it, guys. You've been amazing, and thank you for being so patient with me. Honestly, it's quite shocking. 23 of you in, that's really good. And thank you for giving up nearly an hour of your precious time to do this. So we will do this the same time next week. I forget what I'm doing next week, but it's something equally gripping. What is it? Images, characters, and sound. Yeah. So ASCII, metadata, pixels, sound. People always find this bit really difficult about sample rate, bit rate, duration, bit depth, and so on. So that's what we'll do next time. And I will see you in exactly a week. Be good. Have a great week, guys. Have fun. Take care. Bye-bye.